start with the topic first. So navigation basically is an application of spherical triangle. So you can see that on this picture, there is a, let's say, a ship here going from point A to point B along the circle. So the square circle here, A here to B, right? So you move along a great circle. So this is a great circle here. Great circle means the circle pass through the center of the earth. So this great circle part along the great circle, right? So you go on this path here. Our interest is actually what is the distance it travel. Okay, the distance travel from A to B. So how do we find the distance travel? Usually the distance travel are measured in degree and minutes. So we go along that way to find degree and minutes first. Later on, when necessary, we can convert to nautical miles. Okay, to do this, let's assume the yellow part is a North Pole now. So North Pole is here. So the meridian running A on the great circle to North Pole is here. So this is joining the North Pole to A to North Pole. And then the other one is North Pole to the B. So this is a spherical triangle now because they are formed by great circle. So now if you remember the direction of the North Pole, usually we use this one, right? Direction of the pole. So look at the diagram here. The angle alpha, okay, alpha indicated in blue there, is actually the bearing of the ship heading to. So this is called an initial course. So the ship is heading in this direction. So the way you draw it, you can see that this alpha here, direction is going toward the northeast direction, right? So because actually you can see the direction northeast, right? So it depends on the direction you draw. So this one in this case, for example, this is in towards northeast. Going the north side and going the east side. Okay. And how about the beta? Beta is the wind angle now. Is called the final course now. So initial course is the direction the ship move. In this case, the picture shows northeast direction towards northeast direction, and then the final course is the green color one. Okay, measure to the right. Okay, that is the final course. So I may WhatsApp this to you. So at the picture here. As a start. Okay, so let's WhatsApp this to you first. Okay, I see still have two people haven't gone on board yet. Okay. Supervisor to Muhammad Safi. Okay, then let's go back. Okay, this is an important lesson. Okay, I'm going to introduce a few term definition of few term. I know that alpha is the initial course, beta is the final course, P is the North Pole. So I'm going to introduce other things here. What is the term of PA, right? So in this case, I blow out the picture here. Now the side PA, the PA is actually, let me erase the color first. Okay, note alpha and beta here. So PA is the length of this side here. So let's draw here PA. So P to A here. So this line here, okay, is called the co-latitude of A. Okay, co-latitude of A is here. Okay, PA is co-latitude of A, and then the PB similarly is called the co-latitude of B. Okay, basically co means complement. Basically, you see a co basically complement of latitude of A. Okay, co actually means complement. Okay, co actually means complement. 90 degree minus this, right? Okay, so I introduce the co-latitude of A, and then the AB, the great circle distance now. Okay, great circle distance is AB here. Great circle distance. So this distance is great circle distance between A and B, and the angle P. Okay, angle P, we have this one. Different longitude between A and B, right? Because A and B have longitude there. So this difference in longitude is an angle P now. Okay, P and AB are corresponding. AB is a side, P is angle. I already explained the alpha, the initial cause of the movement, and beta is the final cause. So now I go back to another word. This is an important word here called the vertex. So what is actually a vertex here? Vertex is actually the nearest point to the pole. Okay, vertex is the nearest point to along the great circle to the pole here. The vertex is highlighted in orange. What does it mean? It means that, okay, the vertex will be somewhere here. If you join the angle P, go down, hit 90 degree. This is the vertex V. Okay, vertex V. So vertex is the nearest point to the pole. So it could be nearest point to the North Pole if it's choose the North Pole, or nearest point to the South Pole. So you drop 90 degree there. So what is so good about 90 degree is that you can use a Napier's rule, right? Usually if you want to find a vertex, you use, so usually to find a vertex you need Napier's rule. That means you need to draw Napier's wheels, and usually one because of 90 degree here. So because of this special 90 degree here, right? So the vertex is the nearest point to the pole. So that means that this angle is 90 degree. So I will set this to you. Right. So okay, this diagram here. Okay, with this, I think I can ready to show you first example now. So example, I think is this one, example 9, right? Example 9. Okay, so let's look at this example 9. What is it about? Calculation of example 9. Okay, so let's look at the picture. A ship leave at the point 25 degree 31 minutes 60 degree west and follow a circle track. The initial course is 68 degrees. So what does it mean now? Okay, so let's say you have point A here. Okay, you're going to move to another point. The ship going to move at another point, right? And then somewhere here, this is a North Pole here. So North Pole, pointing to the North Pole, right? So P is a North Pole. So this point A is actually 25 degree 31 minutes and 60 degree west. Okay, location of point ship A. You follow a good circle track. The initial course is 68 degrees. So from here to here, from the North Pole, this angle is 68 degrees. This is your alpha here. So alpha, I use a blue color one. Okay, the initial course 68 degrees, blue color one. Okay, find the latitude and longitude of the north vertex, nearest point to the north here. So if you draw it, let's say nearest point, right? So what means that this angle is 90 degree now. This angle is 90 degree here. This V here, the vertex. So the question is, where is the location of this vertex V here? Okay, this is latitude. This is longitude here. Okay, find out. Okay, find the latitude and longitude of this vertex here. Nearest to the North Pole, right? Nearest to the North Pole here. Okay, so what is actually going on here? So maybe I draw a spear for you to see. Okay, I think it's not here. Okay, so let me draw a better spear. This is spear. This spear is also ugly here. So let me insert a page first. So I draw a big spear here. You see, this is planet Earth. This is equator. Okay, equator here. So center the Earth here. The point A is somewhere here, 25 degree north. Okay, so A is 25 degree north, 60 degree west. Okay, based on the picture here, 25 degree, 31 degree north, right? So this one have 31 degree, 31 minute here. Okay, A here. Okay, so the picture looks something like this. So this is the North Pole. This A here, right? So it moved in the direction of 68 degree bearing until the point reach is B here. So it continues to move, right? It move in the track here. So this is what they want. Okay, where is the location of V here? So what you do is what are the information you have? So I draw this, and then this angle. I see why we call it co-latitude here. Co means complement. So what is this angle here? So angle between the origin and the A with the plane equator. This angle is how much? This angle is actually 25 degree 31 minutes. Okay, 25 degree. Then what is this angle now from here to here? PA, right? So the angle from PA is now, okay, that's why the length of PA now. So let me write down over here. Length of PA is called co-latitude of A, which is actually length of PA, right? It's actually how to do this one. It's 90 degree. Because North Pole is at 90 degree. Equator is 0 degree. So this is 90 minus 25 degree 31 minutes here. So you can subtract there. So 90 degree. So you get this one is 64 degree 29 minutes. So this thing is called co-latitude of A, co-latitude of point A here, and this distance is 64 degree 29 minutes. It means that this distance here is 64 degree 29 minutes, right? This is how you understand the problem. So PA, we know this. Okay, so this you understand the problem, okay? Where the angle comes from, what I call it co-latitude. The co basically the complement of A, right? Complement A means 90 minus A. Okay, so I was at this diagram to you so that you get a better understanding what these things are about here. There are three triangle, right angle triangle here. This 90 degree here, then 90 degree here. So I actually want to know where is the point B here. So let's WhatsApp this to you. Okay, so WhatsApp this to you first. Okay, still have Muhammad Shafi not here yet. Yesterday he was also absent also. Okay. Okay, now I know PA now. So I know PA now, right? So PA, find out that PA is actually right here. Calculation. PA is 90 degree minus 25 degree 31 minutes here. You find that it's 64 degree 29 minutes for PA, right? So this is 64 degree 29 minute PA. Okay, and the right angle, so a bit confused here, so I don't want that color now. So right angle is here. Vertex here. So vertex B here. So I'm going to transverse the right angle triangle clockwise. So this one will be clockwise here, go in, Okay, then this one, right, clockwise. So let's draw a Napier view first. So Napier view, you got top the 2 part, bottom got 3 part here. So starting from V, 90 degree. So the first point, you're going to get the first time transverse clockwise, you get VA first, VA. Then the reach angle A. Then you have a AP. Then reach angle P. Finally, PV and the com below. Okay, we know A angle now. Angle we have 68 degree. And you know AP. AP is 64 degree, 29 minutes here. So draw a view, two information there. So this two information will help you to find out some other information. For example, you can find out what is PV first. Okay, PV, alright. So I want to find PV here. PV, right? PV is a middle part. There are two opposite. One, it is one. I use blue color here. So I'm going to find PV first. Right? PV is an easy one. So I want to find PV first. Okay, find PV. So yellow one. So you can say that PV is yellow one first. So Napier's rule, if you remember, sine of middle part is the product of cosine opposite. Okay, so this is how to find PV here. The sine of middle part is product of opposite here. So opposite, both of them in the lower part of the view. So you have to make a comp there. So sine of PV here, PV is equal to product cosine of comp A, because A is in the lower half of the view, and cosine of comp AP, because AP also on the lower half of view here. Yeah? Okay, then we make use of something we know about cosine comp A. Okay, but cosine comp A is the same as sine A. So they cut down your calculation. Cosine comp A is the same as sine A. Cosine comp AP is the same as sine AP by drawing triangle. So otherwise, you always have 90 minus A, 90 minus AP. Right? So this is an easy way out. So we can find out, okay, sine A is 68 degree. Sine AP is 64 degree, 29 minutes here. So press a calculator and see whether I have it or not. Okay, so the calculator, right? Multiply out and see what happens. Okay, sine 68 degree here. I must make sure calculator in out. So sine 68 here, sine 6429. So the 0.8367. So this is sine PV, right? So PV is equal to sine inverse answer. Okay, so shift sine inverse now, shift sine inverse answer. You get 56 degree 48 minutes. Okay, so PV is this one, but we know that for sine we have this property. So I will remind you when you look at sine function. So you know that when your sine function, say this is theta here, this is also theta here. We know that sine of theta and sine of 100 theta, 80 minus theta here. So you should expect the same answer, means sine of theta and sine of 180 minus theta. Okay, both of them, let's say, should be 0.8367 now. So you know that there are two possible answers now. PV is this thing, or PV equal to 180 minus 56 degree 48 minutes here. Okay, so this will give you so minus 180. Okay, 1, 2, 3, 12. Okay, so there are two possible answers, but this one we will reject here. Why we reject here? Because 64 degree 29 minutes corresponding to 90 degree. So we know that these two are correspond. Alright, then PV is a smaller angle, smaller than 90 degree. So PV is a smaller angle. So PV is a smaller angle now. So the side should be smaller than 64. Okay, so PV is 60, must be 56 degree 48 minutes now, because otherwise it's too large already. So reject here. So let me WhatsApp this to then answer the fun question. I think that some people are asking question there. So WhatsApp this one. Okay, anyone ask there some question there? Let's see. Anything? Okay, so one of them is why the explain why you want to minus, right? Because when you do sine angle, when you do sine angle here, okay, so the sine has this property, okay, sine theta and sine 180 minus theta have the same value. So whatever you get, so I know that sine theta is sine PV is 0.8367. So another possibility is 180 minus theta also have 0.8361. So there are two possible answers here. This will happen for sine, right? For sine, you have to do this. This is a disadvantage of sine function. You have to always have two possibility. Okay, you always have two possibility. That is why after you find one already, the calculator give you a one. Usually is the smaller angle, then the bigger angle you have to find out. Okay, then you see that which one is suitable. The suitable one is you keep, then not suitable one you reject. Sometimes you don't know, you just keep both, huh? But this one we know. So I know PV is actually this one now. PV is actually 56 degree 48 minutes now. So what does it mean, right? PV is 56 degree for 48 minutes here. Okay, so next step I'm going to find out what is V now, right? What is the latitude of V now? So I'm going to copy this to diagram. Next page first. Okay, so then go back to the big sphere I have just now. Okay, so I know PA now, PV, right? PV we find out, okay, we find out PV earlier from the previous view here. PV is equal to 56 degree 48 minutes here. Okay, 56 degree 48 minutes here. So PV here is 56 degree 48 minutes. So what is the latitude of V now? So you can see that you can join O to V. Okay, O to V here. So great circle. Where is this angle now? So latitude, this angle is latitude of V now. So latitude of V is 90 because from 0, equator is 0 here, minus PV. Okay, 90 minus 56 degree 48 minutes here. So you can find out, okay, 90 minus 56 here. Six minutes here, and 48 minutes, 48 minutes. So this will be 33 degree 12 minutes here. So this angle here, this angle we find out is 33 degree 12 minutes. So this is the length. Okay, also the latitude of the V here, right? Latitude of V is 90 minus, okay, from P go down to V, 56 degree 48 minutes here. So the difference give you the latitude of V. Okay, latitude of V means actually what is this angle? Where is this angle? Latitude of V here. Okay, so okay, I'll send this to you now. Picture how everything is related. So then I come back to the picture now. So The latitude of V now is 33 degree, and based on the calculation I have here, is 33 degree 12 minutes, right? So I put here 33 degree 12 minutes north. How come you know it is north? Because direction of ship, right? The ship actually move in the northeast direction, so you continue to move north, okay, north south, right? Actually, you can see V is at the higher point of A, so so you know that V is 33 degree 12 knots, right? So the latitude of V now is 90 minus 56 degree 48 minutes here. Based on this calculation, at 33 degree 12 minutes north. Okay, that's how I get this. So I find the PV already. Next, I want to find P now. Okay, find the angle P, right? So find P now. So I'm going to find P now. Angle P. Okay, angle P here. So let's change the color now. So the one yellow color here now. And then the one the blue color now. I want to find P. Then angle P, right? The angle P I want to find. So angle P here. So angle P, I want to make it the center, middle part. So I have two adjacent part now. Adjacent part, I usually use the green color here. So I use the formula for this now is actually sine of middle part here, sine of middle part. Every time you write down in not formula, but many times you actually remember all this formula now. So this is product of tangent, just on the cosine is tangent now of adjacent part. Okay, so sine of middle part, which middle part I will use yellow here. Adjacent I use green here. Product tangent of adjacent. So the middle part happen to be in the lower view, so I need com there. So this is a sine com P. Okay, sine com P, and then product of tangent. So PV is on top of view, so PV is okay. But AP you need tangent com. Okay, so that's why you get com AP, PV on top there, and then com P. Okay, then you can simplify. Remember last time, what is the meaning of sine com P? Sine com P can be simplified to cosine P, so that you can cut short the working or number or error. So sine com P is same as cosine P. So anyway, tangent PV is tangent PV, just leave it there. And tangent com AP is 1 over tangent AP now. 1 over tangent is 1. Okay, tangent AP is 1 over now, right? So put in the value there. So tangent of PV, okay, 64 degree. The PV is 56 degree 48 minute, right? 56 degree 48 minute here. Times tangent 1 over now is tangent PAP. AP is 64 degree, 29 minutes here. Let's see what is this thing. So let's calculator to find what is cosine P now. Okay, this one is 0.72, 944. So now we can find out what is P now. So P is equal to cosine inverse the answer. Okay, so you can find out this one is 43 degree. And how many minutes here? It's actually 10 minutes here. So this angle P is 43 degree 10 minutes here. So this angle P here, 43 degree 10 minutes. Okay, 43 degree 10 minutes here. What angle P? Okay, 43 degree 10 minutes. Okay, this is how to find angle P here. So now WhatsApp this to you. One part of the solution. I see some question there, so I will answer later. So when you happen to do this, you don't need to find another angle now because cosine inverse only give you one answer, alright? Cosine inverse only give you one answer. So what did this angle P actually tell you? Go back to the big sphere I tell you, right? Big sphere. Okay, I think it's this one. Big sphere here. Angle P is this one. This angle P here. So let me erase this, get one angle P, right? So angle P we find out is accurate. Angle P is equal to we have a calculator, yeah, angle P. Okay, 43 10 minutes. Okay, 43 10 minutes here. So 43 degree 10 minutes here. This angle P. So what does it mean? The ship move to the northeast direction. Okay, the ship move in this direction here, go toward the east side. Right? A is 60 degree west. So the longitude of V now, okay? So longitude is getting to the east now. The longitude of V is what now? It's starting from 60 degree west. You go east. So you go towards to east, right? So the degree will less now. Okay, 60 degree west, go to the east, how much? So 43 degree 10 minutes here. Okay, so you find that whatever left, you get on the calculator here, 60 minus 43 degree 10 minutes here. Okay, 16 degree 15 minutes. Still in the west, but slowly go to the east side. So minus 43 degree 10 minutes, you get 16 degree 15 minutes here. This is the longitude of V. So I can calculate this one based on calculation here. So I show you the calculation here already. Okay, so let's go back. So now you can find the longitude. Okay, longitude of V here is just 60 degrees. Move to the east. Okay, 43 degrees. 10 minutes here. So you get 15 degrees. 60 minutes here. So still in the west side. So this is actually 15 degrees, 15 minutes west. Okay, this is how we get the answer. 16 degrees, or I made mistake there. Check there. 16 degrees. Yeah, 16 degrees, So 16 degrees here. Okay, so this is how you get the latitude and longitude of the vertex V. Okay, let's finish the calculation for example 9. Then afterward, I go back and answer your question. I think there are some people in there. So why is the comp suddenly change to cosine P, right? Why is comp suddenly change to cosine P, right? So this is a question that's in the previous lecture I mentioned there. So let me address this question now. Why comp P, right? So sine comp P. So this is a P, angle P here. So 90 degree. Okay. So this is opposite this adjacent. So sine comp P. Okay, sine comp P here. What is it now? Where is comp P? Comp P is the one here. So this angle is comp P, 90 comp P here. So sine comp P is opposite of comp P. Opposite comp P. Divide hypotenuse of comp P. Hypotenuse, right? Hypotenuse is one. Okay. Hypotenuse of comp P. Okay. So opposite of comp P is actually adjacent now. Opposite of comp P is actually this one, right? So it's actually adjacent of P here. Okay. Opposite of comp P is what? Opposite of comp P is this one. Comp P is here. Opposite of comp P is this one, right? So you take over become adjacent of P, right? Adjacent of P over hypotenuse is what? It's actually cosine P. That's why for next time, sine of comp P, whenever you see sine of comp P is straight away cosine P now. Don't need to worry about 90 minus P, right? Just straight away write cosine P. So this is how these things are related in trigo. Okay, so this is how what happened in example 9. Okay, so there is question example 9, right? So the next one, I want to talk about example 10 now. Okay. Example 10. Find the great circle distance and the initial cost from the position A, 51 degree 10 degree north, 51 degree 10 minutes north, then west side to 55 degree B. So how it look like here. So let's try to draw a picture here. So I have a point A here. Point A is 51 degree, 10 degree north, 10 degree west. Move to point B, okay? So you go to the, continue to move to the west side, see? The west side, go to the west. Okay, so actually point A is here. A is here, 51 degree, 10 degree north, 10 west. You go to the west side, right? Because go to the west for the west now. So to another point, B. So this B is 52 degree. North, 53 degree west. So I want to find the great circle distance and initial cost. So what does it mean? So there's a point P here, North Pole. So join North Pole here. So initial cost is what's the direction? Initial cost is this the direction here now, right? Initial cost is actually measured from the north, right? So this angle is measure this one. Okay, the north here, towards the north here. So this angle to the cost, this alpha, initial cost. And want to find the distance, AB, right? So A and B, so great circle distance AB here. Right? So these are information we need. So let's write down so that it's more clearer here. I don't want to mess up all the letters. And so this is 54 degree. 52 degree, 55 west. Okay, let's see what are the information we know. Okay, this one, I want to find out what is PB first. PB is called a co-latitude of B, right? It's 90 minus the latitude of B, which is 52 degree there. So you get 38 degree. So PB is 38 degree now. Okay, then PA will be co-latitude of this. Of A here is 90 minus 51 degree, 10 minutes here. So you should get 38 degree, 50 minutes. Okay, 38 degree, 50 minutes here. Okay, so I have PA and PP there. So I want to find what the information I have now. So do you know what is angle P, right? Angle P. So angle P is from 10 degree west, starting from 10 degree west here, go to 55 degree west. So the difference of angle P is 55 degree minus 10 degree, and the difference is 45 degree. So this angle is 45 degree now. Okay, so now it's a typical part. You are trying to find the angle. Let's say the angle P opposite is called small p, small p here. So this is the typical time. You can do the cosine law now. So cosine law, what is this all about here? So you can highlight. Okay, see the correspondence. This one angle and side, and then the other one. Okay, this is, let's say this is a here, opposite angle A here. This is a B here. So this is another one. You can use the law of cosine, say that, okay, cosine of side P. Okay, all this formula will be provided, but if you know, then it's easier. Cosine of side P here is a cosine of A, cosine of B plus sine of A, sine of B, cosine of angle P for spherical triangle, right? Because the theorem is spherical triangle now. So this is angle P, this angle P, and then I have A, spin color one. So this A here, and then B here, B here. Right? This law of cosine. So put in the number. So A is equal to cosine of 38 degree. B is cosine of 38 degree, 50 minutes. Then A again, 38 degree. B is 38 degree, 50 minutes here. Then cosine angle 45 degree. So this time you got a number. This number is 0.8868 here. So you can find P now. P is cosine inverse 0. Answer here. So this will give you 27 degree. Best calculator. Okay. So 27 degree. What's that? Okay, so it's 27 degree, 31 minutes, 32 minutes here. So, which is okay, but if you look at the answer, is nautical miles. So nautical miles, you have to do something to convert this. Okay, nautical miles is so you must, this is also 27.52 degree. So convert them in terms of minutes here. So then 27.1. So convert nautical miles and multiply by 60. Okay, multiply by 60. So 27.52 times 60, and then you get 1651. Okay, 1651 nautical miles. So that's how you find the distance between AB, right? So distance between AB is 1651 nautical miles. So okay, we'll send it to you first. So this time I use the law of cosine. So this time P is 27 degree 32 minutes. All right. Okay, now next I want to find the initial cost alpha. In this case, I need to find angle A. Okay, so let's copy this thing. This page here. Okay, define angle A now. So then find initial cost, okay? Find angle A. How do you find angle A here? There are two ways. Okay, angle A can two ways. Okay, you can use a sine law or cosine law, right? In this case, let's use a sine law. Sine law is easier in terms of calculation is easier. Then you just have to make sure that you get a correct answer. So sine law say that in sine of angle A over sine of side A here equal to sine of angle P, okay, over sine of side P, because I know this is already. So sine angle A, I don't know, sine of side A is 38 degree. Okay, angle P is 45 degree. Side P is 27 degree. 32 minutes here. So sine A is equal to sine 45 degree times sine 38 degree over sine 37 32 minutes here. So we can find out what is this A here. I think this A is actually A. Let's calculate it. Sine 45 times sine 38 here over sine 27 32 minutes here. So this 0.94175. So A equal to sine inverse now. Answer. So sine inverse. Okay, 70.21. So one possible answer is this one, or another one. Remember the sine one always have this property. This is the theta here. This 180 minus theta here. So you have two possible answers here. This theta, this 180 minus theta here. So we know sine of theta and sine of 100 theta, 180 minus theta here can be both equal to 0.9435. So your A could be 180 minus 70. Okay, we know that this is actually a big number now, which we will reject here. Okay, about 109. 40 minutes here. Okay, so this angle is rejected. So why is it rejected here? A cannot be so big, right? Because 45 degree, okay, 109 degree is too big. Is disproportional, right? So by looking at this 45 degree at 27 minutes only, right? This is 109, much bigger already. So we check this number. So what is the alpha now? So alpha is 2. Alpha is alpha in this case is 360, one round, minus 70 degree, 21 minutes here. This is about, look at the answer, should be 290, right? So 360 minus 70 degree, 21 minutes here. So it's 289, so it's 290 now. True bearing. Okay, initial cost. So this is how you answer question 10. Now this one, if you use a law of cosine, will be much better in the sense that you don't have less confusion. You get confirmation straight away. Don't need to do, okay. So the guess answer, okay. So if you do the law of cosine, it is much better. But I think I just do the simplified way because law of sine looks easy calculate. I just make decision later. So this is actually question 10, example 10. Wow, this is very tough. I look at question 11. I may not able to finish question 11. Example 11. Okay. Oh, okay. Question 11. Wow, question 11 is quite long question. Okay, I think maybe I leave it for next one because I don't think I finish this question, right? So question 11, I'll leave it next time, next Wednesday, right? Afterward, then we do some revision. Okay, so any more question today? I will stop here. Okay, any people not here? I see Muhammad Shafi is not here. So I will stop recording a bit.